All right, let's have a look at naming some ionic compounds. Here's our first one, CrBr3. So by convention, we put the cation first and we put the anion second. So the positive ion goes first and the negative ion goes second. And there's one Cr cation and then there's three Br anions. And we can tell there's three because the little subscript 3 just here. I can tell that Cr is the whole cation. So it's not just the C, it's not CRB, it's CR, because the first letter, or the capital letter, always indicates the start of a new element. So because C is capital, it means, and then R is lowercase, it means that CR is the cation, and then because B is a capital letter, and then R is lowercase, it means that this is the anion here, Br. So let's scroll down, oops, to our periodic table, and see if we can find CR and Br. Okay, great. So I can see CR is right here, and then there's Br right here. Now, this version of the periodic table doesn't give us the full element name, so we've got to scroll back up, and we've got to try and find, hey, where's CR and Br in this list of elements? So here's CR right here. It's element number 24. It's chromium. And where's Br? Br is right here. It's bromine with an atomic number of 35. So now that we know that, we have all the information needed to go and name this thing, or name this ionic compound. And we're going to put the cation first, so it'll be chromium. And the cation remains unchanged, so it's chromium as listed on the periodic table, and that's exactly how we're going to write it here, it's chromium. The second element, the second ion, the anion, we're going to change the ending of it. We're going to change the suffix or the ending. And now usually, if I just write out how it appears on the periodic table, usually you'd say, well, it's bromine. It's going to be BROMINE. But that's not how we're going to talk about it when it's an ion. We're going to get rid of the ID, the INE, and we're instead going to add on IDE to make it bromide. So the official name of this compound is chromium bromide. And note that although we had one chromium cation and 3 bromium anions, we don't need to indicate that anywhere in the name because ionic compounds exist in fixed ratios. That means that chromium bromide is always going to exist 1 chromium ion to 3 bromium ions, and therefore it's a 1:3 ratio, and it's always going to be like that, and it's never going to change, and therefore we don't need to indicate the numbers of each that we have. Let's have a look at example 2. It's AgI2. Cation first, anion second. Let's scroll down. Let's try and find these guys. I'm just going to jump straight to the list here. Can we see Ag anywhere? Yes, we can. It's right here. It's element number 47. It's silver. And the other one was I. So where's I? There it is right here. It's iodine, element number 53. Okay, let's scroll back up here and let's try and name this thing. So the cation will go first. And the name doesn't change. It's silver. And then the anion goes second. So it's iodide. And note that I've changed the ending, the suffix, to IDE instead of how iodine usually appears on the periodic table as INE. Oops. Okay, let's have a look at the next one. PbF2. Well, PB, scroll back down, is lead. And what was the other one? F2. So F is, where's old F? Fluorine right there, element number 9. So let's try and name this guy. So lead, first word remains unchanged. The cation remains, its name remains unchanged. And then fluoride. Note the ending there, IDE. Let's have a look at the next one. Zn. So Zn is zinc, and the other one was S. Oops. S right here, sulfur, element number 16. So that's going to be zinc. sulfide. NiO. There's N, and right below it is O. So N is nitrogen. Whoops, nope, sorry, I've made a mistake. That's not it. It's Ni, isn't it? So Ni is right here, nickel. So here's nickel, element number 28, and oxygen. So O right here. So it goes and becomes nickel oxide. All right, let's have a look at F. It's Pb3 and then in brackets PO4, close brackets 2. This one here is interesting because this in brackets is a polyatomic ion. It's phosphate. And the Pb is lead. It's on our periodic table. I think we've already used an example with lead. Here's element number 82. But the ending here is phosphate. Okay, the anion is phosphate. So we go lead, phosphate. We've got something interesting happening here. Note that I didn't change the ending of phosphate to IDE. The phosphate ion, the phosphate polyatomic ion, is already named correctly on the list of polyatomic ions that you received. So it's always going to be ATE. It doesn't need to be changed. Let's have a look at the final example. Again, we see another polyatomic ion. This one's nitrate. The cation is copper, and the anion is nitrate. So let's find copper just real quick on our periodic table, on our list of ions. Sorry, list of elements. Here's copper, Cu, and then let's write its name, copper, nitrate. All right, so note that nitrate does already have the correct suffix, ATE. That's how it's listed in your list of polyatomic ions, and we don't need to change its name at all. It just stays as nitrate. So these ones here are a little bit different. So F and G are a little bit different to A through to E in that we have polyatomic ion present, and that needs to be named ATE instead of IDE. It's also a really nice way to sort of figure out that this one here is, so when you're working backwards, when you're given the name sorry, let me start again. When you're given the name of an ionic compound, it's a really nice way to be able to work backwards and say, hey, how do I know that's not nitrogen and that's a nitrate group instead? Because it's got the ATE ending. We know that this is what it's going to look like, and it's not just going to be a single nitrogen atom.